Hey everybody, let's do this second page here of this worksheet on angled projectiles. So we changed it, remember, from 58.8 meters per second. We're shooting up at 60 meters per second, so that is our vertical speed. And we're going to go to the side at 20 meters per second. So first thing is, they say fill in the table with the horizontal and vertical displacement. So horizontally, we are going to be using this equation. Our displacement horizontally is our horizontal velocity times time. So for us, our horizontal velocity is 20, and so we will just take 20 times whatever time we're talking about to get where we are. So 0 times 20 is 0, 1 times 20 is 20, or you can just count up. We're going to go 20 meters each second, so we'll go 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, and 240 will be our horizontal distances there. Now vertically, it's a bit more involved here. So vertically, what we're going to do is use the third equation. Our vertical displacement will be equal to our initial vertical velocity times time plus 1/2 times g, our vertical acceleration, times time squared. So when we plug in for the specifics of this problem, our initial y velocity is 60, so we'll do 60 times t, plus 1/2 our vertical acceleration, g, is -10, times t squared. So we'll keep using this with different seconds to plug in here. Now 0 is easy. If you plug 0 in there at 0 time, you're at 0 height there. So after 1 second, let's do an example where we plug it in after 1 second. So what if we plug in 1 for t? We'll get 60 times 1 plus 1/2 times -10 times 1 squared. So 60 times 1 is 60. 1 squared is 1 times 10, -10 is -10. Half of that is -5. So 60 minus 5 is 55. And that is what would go in right here. So after 1 second, we are 55 meters up. You're going to repeat this process for the other time. So if you plug 2 in here, you'll get 2 times 60, which is 120, and then 2 squared is 4 times 10 is 40. Half of that is 20. So 120 minus 20 is 100. So now we are up 100 meters. Plug it in for 3 seconds, and you will wind up getting 135 meters. Plug it in for 4 seconds, and you will wind up getting 160 meters. Plug it in for 5 seconds, and you will wind up getting 100 and, let's see here, let me make sure. Let's do this one. So 25 here, 15 more, 75 meters, sorry. And then if you plug it in for 6 seconds, you'll get 180 meters. Now, one thing I want to do here real quick is look at this. Here we jumped up by 55 meters from 0 to 55. Then from 55 to 100, we jumped up 45 meters. And then we jumped up 35 meters, and then we jumped up 25 meters, and then 15 meters, and then 5 meters. So there's actually another little pattern sort of hidden within that table there. Now, if you plug in 7 seconds, this number starts to get bigger, starts to bring this back down here. So if you plug in 7 seconds, you actually get 175 again, just like here. And if you go over here and plug in 8 seconds, then you actually get 160 just like you did here. So you start to see that there is a pattern that it brings you back down to the ground there at 0. So here is all of our horizontal displacements and all our corresponding vertical displacements. So the next thing they want you to do is to graph it. So actually I went ahead and put it here so you don't have to watch me drawing dots. And if you are careful, look at this beautiful little parabolic shape that you get here. The truck kept on trucking at 20 meters per second sideways, but so did the ball. It went 20 meters per second sideways the whole time. So they say, will the projectile land in the truck, behind the truck, or in front of the truck? Assume no air resistance, so it will land in the truck. And the reason for that is they have the same Vx. So the Vx of the truck and the Vx of the ball are the same. So the ball stays right over top of the truck the entire time.